Yes,
All
yes,
right.
me.
All right. So let's go. This is 2019.
The paper looks shaky.
Now there's some new questions. All
Mm.
right. So it says express in the form a plus bi. So all we're going to do is rationalize. So we're going to
Check.
multiply by 1 minus I over 1 minus I. And so what we're going to get is, in the denominator, we're going to get 1 square minus I square is 2. In the numerator, we get minus 2 times 1 is minus 2. Minus 2 times minus I, minus and minus give us plus. So we get plus 2I. 2I times I is just plus 2I
Plus
squared.
2I squared.
And then we have 2I times
2, it'll be minus 2, which is 4, minus 4. Minus 4 plus 2I.
plus 2I. So what we end up with now is 2I squared is what?
Negative 2.
Wait, what did I do right? 2 minus 2 times minus I, that's plus 2I. 2I times 1 is 2I. 2I times minus I is minus 2I squared. Sorry, this shouldn't be plus 2I squared. That's minus 2I squared.
Okay.
Yeah. And then I
So
squared is
that
minus
be
1.
2 minus 2, 0. I add it
That's
back with
0.
2.
4I
4,
over 2.
yeah,
4I over 2, which is 2I.
2I. So one is dog.
Easy. Soft.
So,
All right. Question 2. It asks us now the quadratic equation. Oh, let me just send this paper in the chat as well.
sir,
Right
just
here.
WhatsApp me 2018 and 2019.
All right. Give me a second. All right, so the 2019 paper is loading. It's sending in the chat right now. So it asks for the equation with this root. 2 plus root 3i and 2 minus root 3i. So first we need is the sum of the roots. The sum is going to be 2 plus 2 is 4. Agree with that?
Mm-hmm.
And the product is going to be the difference of 2 squared, which is
The
going to be
sum,
2
sir?
squared. Yeah, the sum is 4. Because the two roots are 2 plus root 3i and 2 minus root 3i. So what we're adding is 2 plus root 3i. And then we're adding it to plus 2 minus root 3i. When you add them, the sum that you're getting is 4.
Oh,
Yeah.
right.
And then the product of these two is the difference of 2 squared, which is 2 squared
So it's x
minus
squared minus the sum of the roots
root
plus
3i
the product of the
squared.
roots.
Yes, that's the formula we're going to use. So it is 2 squared, which is 4, minus root 3 squared is 3,
Root 3.
and then I squared, and then I squared is minus 1. So we're getting 4 plus
4
3
plus 3, 7.
is 7. So it
All
is
right, so
now
it's
x
x
squared
squared
minus
minus
4x plus
minus the
7,
sum of the roots times x plus the product of the roots, yeah.
which is cat.
From, what you call that now? From unit 1.
Yeah. So that's a new question for 2019. This is a new
Cubic
question.
equations and
Question 3. It asks for the modulus of this complex number. What's the modulus of this complex number?
the square root of a half plus the square plus negative half.
Nice. So it's really just half square plus half square
Right.
square rooted. So half square is a quarter. A quarter plus a quarter. And then we square root it, raised to the half power. So we have a
1 over
quarter
root
plus a
2.
quarter. Quarter plus quarter is what, a half? And then we square root a half is 1 over root 2. That's option B. Question 4. Just look at question 4 and tell me the answer. It's easy. Look at question 4 and tell me the answer. -1. Because we're just going to use De Moivre's
The Moivre's theorem. So it's
it's
that
going
the
to be
cosine of
4
4
pi
times
over
4
4,
pi times 4, pi over 4
which is
plus
just
I
cosine
sine.
pi
Yeah,
plus I sine pi. That's De Moivre's theorem.
the cosine of pi is minus 1. And the
And
sine of pi is 0.
0.
Yeah.
So it's -1. Easy. Easy question. Question 5. It says if z minus 5 plus 2i equals 3, what is the locus?
Yeah, so the center is going to be -5 and -2. And then
No,
you're
it's
going to have
not
a radius of 3
-5.
units.
The
5 and
center,
-2.
5 and -2. Very good. It can be written as z minus 5 minus 2i. Remember, always put it
5
as
and
z
-2.
minus a. Very good, Cheyenne. So yes, 5 minus 2. 5 and minus 2. That's option D. Easy. Soft. Question 6. Y is equal to tan inverse of 2x. Then what is dx? But now this question right here
Cat.
is asking dx by dy. Look at the question, it asks the dx by dy.
No, so CXC, you want to mash up some people in the examiner.
Yeah?
You know them people that you want to mash up the mutated. You know?
So look how easy I can do this. If y is tan inverse of 2x, then what I can then say is tan y is equal to 2x. Agreed? Tan y is 2x. You agree with that?
Yeah.
And so then what I'm then telling you then is that x is equal to tan y over 2. You agree with that? X is tan y over 2. And so now I can differentiate both sides with respect to y. So I'll get dx now by dy is equal to, when I differentiate tan, what do I get?
Secant square y.
Secant square y. Secant square y over 2. Now what's secant square y?
What's
Secant square is 1 plus tan square.
Yeah.
And 1 plus tan square, well, tan y is 2x. And so
The 2x plus 1.
Secant square y, so it's really going to be work out to be equal to 1 plus tan square, and tan y is 2x. So it's 1 plus 2x all square, which is 1 plus 4x square. 1 plus 4x square
1 plus 4x
over
square.
2. 1 plus 4x square over
But that's not
2.
the sir.
So clearly this question must have, this is a mistake again. This is a mistake. They made this mistake in 2014, I believe, where what they were
And I
asking is
can bet
dy
them
by
gonna make the
dx.
mistake again.
So this should have been dy by dx. dy by dx, which is 1 over dx dy. If you're to take 1 over dx dy, then you see the option right there, which is 2 over 1 plus 4x.
Yep.
You flip it. So yeah. What they were trying to do is they asked this question, I believe, in 2007, dx dy, and they had this answer right there. But then they changed the question to dy by dx I know they're trying to rechange back the question to dx dy, but they forgot to change the solutions with it as well, the options. So that's what happened when they're lazy to make new question. So they're trying to change up what they ask for this same question. But easy question. Question 7. So all you need to do is find the argument of z. And the argument of z is tan inverse of 1 over root 3. What's tan inverse of 1 over root 3?
The argument is 1 over root 3, which is
Pi
30
over
degrees.
6.
Pi over
It's
6.
pi by 6. Yeah.
Pi by 6. So it is option B.
We need to know the modulus. So it's the square root of root 3 square plus 1 square,
Which is clearly 2.
which is 3 plus 1 is
Square
4.
root
Square root of 4 is 2.
2.
Yeah.
Easy. Question 8. This is a repeat question from last paper. What did we get? Option B. Remember? It was 2 pi over 3. Option C. From
C.
2018.
Yeah,
Yes.
see.
C. So we don't need to do these repeat questions that we did from last paper. Right. Question 9. It is asking for the derivative of y equal ln cosine x over sine x. So no, this is easy. Just rewrite it as ln cos x minus ln sine x. Ln cos x minus ln sine x. Then how do you differentiate ln function? It's 1 over u times du. So the derivative y prime is equal to 1 over the derivative of cos x is what? Minus sine. So it's minus sine x over cos x, minus sine x over cos x, minus the derivative of sine now is cos. So then we get cos over sine. All right, easy question so far. Only thing we need to do now is join it as one fraction. So I'm going to join it as one fraction with cos x and sine x as the denominator. Cos x, sine x. And so what we end up getting is cos into cos x sine x leaves sine x. So we're getting minus sine square x minus cos square x. Now minus sine square x minus cos square x is what?
Yeah, I'm gonna be there right now.
That's negative 1 in the numerator. So the numerator works out to be negative 1 over cos x sine x. Now negative 1 over cos x, I can write negative 1 over cos x sine x as negative 1 over cos x times 1 over sine x. Then the negative 1 over cos x is minus sec, and the 1 over sine x is cos x. That's option B. Very easy question. Soft, a capital T. All right. Option 10, question 10 rather. F of x is ln 2x, then f double prime of x. Well, f of x is ln 2x, and so f prime is equal to, we differentiate ln 2x to get 1 over x, because it's going to be 2 over 2x, which is 1 over x. And so f double prime is just equal to, we differentiate this again to get this x, 1 over x is really x to the minus 1. So what we're going to get is minus 1, x to the minus 2, which is minus 1 over x squared. Minus 1 over x squared. That's option D. Easy question, soft. Question 11. Question 11 is asking for the integral of 1 over 1 minus sine square x. Right? So we want the integral of 1 over 1 minus sine square x. So that is just the integral of 1 over cos square x. And integral of 1 over cos square x, 1 over cos square is sec square. So we're really integrating sec square. And the integral of sec square x is tan x. That's option A. Easy question, soft. All right. Question 12, here's a new question. Integral of 2x e to the minus x. All right. So what we can do is use by parts. So we're going to use the integral.
Any intruder? Yeah.
And this is uv minus the integral of v du. Right? That's what we're going to use. Integral of u dv is equal to uv.
So what's number 10? Sorry about that.
What's number what?
Number 10.
Number 10 is dog.
Okay.
All right. So question 12. This is what we're doing. So this is our u. U is 2x. So u is equal to 2x. And so du is 2. Du is 2. And then our dv is equal to e to the minus x. And so our v is actually, or v is just equal to minus e to the minus x. And so it's uv, this integral is now uv, which works out to be minus 2x e to the minus x minus the integral of v du. The integral of v du is minus the integral of 2 times e to the minus x. Now this minus, I'm going to factorize it out and put a plus e to the minus x. And so this works out to be minus 2x e to the minus x. Now this part works out to be, when you integrate, you divide by -1, so it is minus 2e to the minus x plus some constant c. Now look at the options. What you're going to have to do is factor out minus 2e to the minus x, and we're left with x plus 1 in the bracket. So that is clearly option D. You're going to factor out minus 2x e. We're going to factor out minus 2e to the minus x, and so we're left with x plus 1 in the bracket. That's option D. So this is a new question. So I just like to write new. N stand for new. 2012 is a new question right here. I don't think there's any
So
other.
why do I have x plus 1 in the bracket?
Because they factor out minus 2x from these two terms.
Or minus 2e to the x?
Yes.
Oh, okay.
Yeah. Question 13, big repeat question. We've done this so many times. Question 13, we said was, I believe, dog. Is it dog?
Yes, sir.
Yes,
Yes.
sir.
Repeat question. That's a every week repeat question. That's question 13. Question 14, we did that in the last paper as well. That was, I believe.
What's number 13 again, sir? I didn't see the option.
Question 13 is dog.
Dog.
Yeah. And question 14 is bat. So that's a repeat question. Question 15, this is a repeat question as well. We said that was minus pi by 4. We did that in the last paper.
Huh?
So now we see in the repeat questions. Question 16, which one converges? That's but. We did that in the last question as well. So this is repeat from 2018. Question 18, big repeat question. Question 18, I believe, was what was question? What's this one?
1/20.
1/20? That was A. Repeat question. Easy. All right.
Number 16, answer A.
A.
Yes, number 16. Big repeat question. Nice. I love that. I love how it's so nice. So when they repeat, we just tick off with confidence in the exam. Shade with confidence. Nice. All right. Question 19. Sin x, I believe, is A. X minus x cubed over 6. That's a repeat question as well. All right. Question 20, another repeat question.
Sir,
D. Yeah.
sorry, I got too fast.
I'm not too fast. Questions that we do from the last paper.
That was 17 to 19.
Yeah, 17 to 19. Remember, we looked at this one. We divide through by n. That was 3.
That was 3.
This converge. This question we do every week. That was 1/20. Question 19 we do every week. Maclaurin series for sin x. That's x minus x cubed over 6.
What?
And then question 20, we did this in the last paper.
Yeah.
And that's D. All right. So CO 2019, nice so far. Nice paper. All right, question 21. That's question 21. This is a repeat question as well.
E.
1 and 3. Right. 1 and 3, that is B.
And I'm sure that
All right. Question 22. What's 22? What's 22?
E.
Boy.
Boy, 1 and 2. Nice. Question 23. We just did this question. What's 23?
135.
135. Nice. What's question 27?
Yeah. E.
Nice.
Yes.
So many questions repeat. Nice. All right. Question 24. What's question 24? All right, now look at this for question 24. They had asked us for this, the sum from 1 to n is this, and we said that it's equal to n
1 and
plus
24
1.
check.
Yes, so all you're asking us for is the limit as n goes to infinity of this part works out to be n over n plus 1. And the limit of n over n plus 1 is 1. Easy. So, question 25. Now, question 25 says that the equations x cubed minus x minus 3 has one real root and a particular interval. All right? So let's try the interval 1, 2. When x equals 1, we're getting that f of 1 is equal to 1 cube minus 1 minus 3 is less than 0, And f of 2 is equal to 2 cubed minus 2 minus 3, and that's greater than 0. And so therefore the root lies on 1, 2, and so therefore n must be equal to 1. So that is option A. Easy question. Question 26. Sorry about that. 26. It says find. Now this is asking us for the sum to infinity. All right. Now sum to infinity is a 1 minus r. So this is a new question. New question. But it is a over 1 minus r. The first term is where we're plugging in as 1. When n is 1, we get anything to the 0 is 1. And so the first term is 2 over 1 minus r. So we need to know the common ratio now. The common ratio r is going to be the common ratio now. Common ratio is the second term.
A is the first term now?
Yes. So the second term right here would be a quarter. When n is 2, we get a quarter times 2 is a half. A half divided by the first term. And the first term would be when n is 1. 1 minus 1 is 0. A quarter to the 0 is 1. 1 times 2 is 2. So what is a half divided by 2? That's a quarter. The common ratio is a quarter. And so this works out to be 2 divided by, yeah.
So you find like the first and the second term, sir, and then you try to find the common ratio from there.
Yes, you find the common ratio from there. And then you can use the sum to infinity formula, a over 1 minus r. So it works out to be 2 times 3 quarter. So it works out to be times 4 over 3.
Times 4/3.
That's 8 over 3.
No, 8 over 3.
Easy question. Soft. Imagine this is 2019. Too easy. What's question 28?
27, sir. What is that, dog?
27 is cat.
Oh, cat.
What's 28?
Yes, sir. D.
28.
Nice.
28. Dog.
Dog, yep. All right. Question 29. What's question 29?
29. 29. Boy.
Very good. Repeat questions. So we should run through those repeat questions.
Number 30.
All right, question 30.
That's
Question 30. All right, this seems a new question. So it says apply the bisection method.
Dog, you get to know,
twice.
sir.
Repeat.
Dog. Dog.
Dog. This is a repeat question.
I think so. Yeah.
Okay, well, let's just do it again. So what we have to do is realize that f of 0 is going to be e to the, anything to the 0 is 1. So that's 1 plus 0 plus 0. So f of 0 is greater than 1. And then f of 1 is going to be less than 0. Now we need to find the midpoint of 0 and 1, which is 0.5. F of 0.5. F of 0.5 is e to the 0.5 times 0.5 plus 0.5 squared minus 3.0.5. So that works out to be e raised to the 0.25 plus 0.5 squared minus 3.5 times 0.5. That's less than 0 as well. Less than 0. And so the root lies between, so the root alpha lies between 0 and 0.5. That's when you apply one bisection method. That's one. So no need for bisect it another time. So let's apply bisection one more time. So applying the bisection one more time. 0 plus 0.5 divided by 2 is 0.25. F of 0.25, f of 0.25 is equal to, well, that works out to be, we put all of that in our calculator, and it's greater than 0. And so yes, so the root will lie between 0.25 and 0.5. Yes, you're right. Yeah. It's a repeat question, yeah. That's B. All right. What's question 31?
Huh?
What's question 31?
31.
Yeah.
Dog.
Yes, very good, very good, very good. So they're trying to trick people. Notice that the last time they had this as 2n, remember?
Right, sir.
Yes, sir.
They're trying to trick people, but they can't trick us. We're too good for that one. All right. Question 32. A repeat question. It says, from the letters A, B, C, D, E, the number of 3-letter words that can be made if no letter is repeated. If no letter is repeated, how many words can we make?
What, 5 factorial?
5 factorial. Yeah, 5 factorial, which is
120.
120. Easy question.
Yeah, but it said 3-letter words.
Wait, it didn't say 5?
No, sir, 3-letter words.
Yeah, sorry about that. Don't jump the gun, don't jump the gun. Let's not jump it. It says a 3-letter word. So let's draw our boxes.
5 times 4 times 3.
Yeah, 5 times 4 times 3. So we can choose 5 letter here, then 4, then 3. 5 times 4 is
20.
20 times 3, that's 60.
60.
Yeah. As it's a 3-letter word. Very good. Nice. Question 33. This is a big repeat question. What's 33?
A.
Nice and easy. Oh. Question 34. Big repeat. What's 34?
Dog.
E. Nice and
Yeah.
Question 35. Big repeat question. What's 35?
Boy.
E. Very good. Easy. Question 36. What's question 36?
Dog.
Dog.
Easy. Soft. Big repeat question. All right. Question 37. What's question 37?
A.
Repeat question. Easy. Soft. Nice. That's a probability that the product of the two numbers is prime. I'm thinking of an alternate method. Probability of one number being prime right here. I'm calling a prime number n. How many prime numbers are right here? This looks like 1, 2, 3, 4, 5 numbers. So the probability of getting a prime number Probability of getting prime number is 2 over 5. That's the probability of getting a prime number from this 5. So, but the trick is that we have to choose a prime number, and then once you choose that prime number, we pretty much want to know what's the probability of choosing a prime number, and then the next number that we choose has to be 1. Wait, they're not 1, 2, 3. They're 3 prime numbers. Sorry, not 2. 3. There are 3 prime numbers right here. That's a probability of a prime number, 3 over 5. And the only way the number is going to be product is that if we choose 3 over 5, yes, this is it. And then the probability of choosing the number 1 now, the probability of choosing some other number, let's call the other number n2. The other number n2 that we have to choose is 1, but there are 5 numbers there. Agreed? And so the probability now of the product of the 2 numbers being prime is the probability of n times n2, which is 1 over 5 times 3 over 5. This method should be more clear. Is this method more clear?
Yes, sir.
Yeah, I think this one is more clear.
Yes, sir.
What I'm saying is we have to draw some prime number, and the prime numbers there are 1, 2, not 1, 2, 3, and 5. So there are 3 prime numbers from the 5 of them. All right? But the thing is, in order for it to be a prime number, the product of the 2, we need to draw a prime number, and the other number should be 1. Because 1 times a prime number gives you back the prime number. The probability of getting 1 though is 1 out of 5. And so the probability of getting the number 1 times the probability of getting a prime number, that's 1 over 5 times 3 over 5, which is 3 over 25. So that's a better method to do it. So that's question 38. Question 39. It says the planes represented by the equations.
Okay.
What is this question? This is a repeat question.
All right. So looking at it, it's 1 and 2.
Why is it 1 and 2?
No, not 1 and 2. Wait.
All right. So first and foremost,
They're not parallel.
Write this in this form. Write it in matrix 2, 1, minus 1, 4. Then this looks like 1, 1, 1, 1. Then this looks like 3, negative 2, negative 1, 2. Now clearly, they are not parallel. None of them are parallel. Think about lines, right? The only way we can have 2 things being parallel is if one line is a multiple of the other. But none of them are multiples of each other. So clearly it's not parallel. So now we need to find out if the system is inconsistent or whether it have a unique solution. Because we know both of them cannot be true. So anything with I and I is out, right? So wait, we don't even need to work it out. Like, look at this. Option is out. Because that just have I only, but we know 2 has to be there. No, you cannot have I and I. You see that? Because we just said that it's either I or it is I. You cannot have both of them. And so
Let's see.
option B is out. Option C, you cannot have I and I, so it's clearly C. So even without working it out, it is just C. Is that clear?
Yes, sir.
All right, so that's option C. Another way to do it was row reduce. So if you have time, you can row reduce. When you row reduce it, you're gonna find that when you solve this system, you're going to get a value for x, a value for y, and a value for z. When you solve this system, so it has unique solution. All right, so that's question 39. Question 40, big repeat question. What's question 40?
A.
A, no solution because this is an inconsistent system. Very good. It's question 40. All right, question 41.
Sir, what's number 39 and 40 again?
All right, so
Never look.
question 39 is C. Question 40 is A.
Oh, right.
All right. Question 41. It says that the matrix M have a determinant of 22. So find A. So let's find A. So 2 times.
The 2 times 1, negative 2, 2 and 2.
Yeah. Plus 5.
Plus 5
Times.
times 1, negative 2.
1, negative 2, A2.
A and 2.
Yeah. Then plus 6.
Plus 6
Times.
times 1, 1.
A.
A and 2.
Right. And I know all of this equal 22. So let's simplify this first. This simplifies to be 2 minus 4. Well, 2 minus 4. That becomes 6. 6 times 2 is 12. That's 12. Is this 12? Plus, this part simplified to be 2 plus 2a times 5. 2 plus 2a. 2 times 5 is 10. And 2a times 5 is 10a. And then the last part is working out to be 2 minus a. And then 6 times 2 is 12. Then minus a times 6 is minus 6a. So all of this looks like it's simplifying to be 22. 22 and 12 is 34. And this looks like 34 minus 4a. Well, 34 plus 4a, and that's equal to 22. That's what it looks like.
So 4a equals the 22 minus 14, which is
What's that? 12? Negative 12?
12. Yeah. So a equals 3.
A equals negative 3.
Yeah, negative 3.
A equals negative 3.
So number 41 and A then.
Yeah, so that's a new question. So we'll put N for new.
New and simple.
New and simple. Soft. Capital T.
That is how I want my paper to be.
Exactly. Question 42 is a big repeat question. What's question 42?
I think you get dog.
Dog. Nice. Big repeat question.
Roots them complex. Theta in another form here.
Yes. What's question 43? We just did it in the last
43 x
paper.
squared.
X squared. Nice. All right. Almost there. Question 44 is a repeat question as well. What's question 44?
A.
A.
A. Nice. Easy. Soft. Question 45. What's question 45?
What answer?
Just did it, you know.
Plus minus, plus minus, plus. There's plus 1, plus the determinant of 1, 4, 0, and 5. Cat.
Cat. Nice. Very good. All right. So that's it. We've covered all the papers from 2008. Yeah.
Send email me the clean sheet for 2018 and 19 and the
2019. Yes, I will. I won't send these markup papers. I'm going to send the clean paper.
yeah, I have a
The
solution on
solutions.
top.
Yes, I'm going to send the solutions as well as the video, the link of our class session.
Okay, sir. Thank you.
All right. So, best of luck next week, everyone. And please, as soon as you finish the exam, just email me and write soft with a capital T.
All
Yeah,
right.
nothing for do.
All right. So have a good night, everyone.
Okay,
Yes,
sir.
sir.
Same to you. Thank you very
Sir.
much.
Thank you very much for all the classes.
Charge you.
Alright.
It was great having you as a maths teacher, sir.
All right. All right. Take care, everyone.
Okay,
Sir,
sir.
sir,
Yeah.
link me on WhatsApp.
All right.
Sir,
Yeah,
make sure to
yeah.
WhatsApp me the 2 clean sheet papers, and
Yes,
to email me this
I'm going
link.
to email the clean papers right now. All right.
Ebo Asani.